Hello and welcome to Domain Expert. My name is Harry Moreno. This video is going to be about writing a solution for Advent of Code Day 1. So today is December 1st, and Advent of Code, for those who don't know, is a challenge that happens every year for throughout the month of December. And basically, a programming challenge is released every day at midnight Eastern Time, United States. So I sort of missed it, but this is day of, so it's still in the spirit of it. And basically, I want to go ahead and, since this is a new channel that I have going on, my understanding from the people I've talked to that do YouTube, they've told me that you sort of want to get like a decent corpus, amount of videos on your channel, so that when people do come across it, they're able to engage and see lots of things on your channel. So I feel like this is perfect. Doing Advent of Code, it's 25 days, and I figure I could probably crank out an hour worth of content for 25 days. I might not do every day, I might not stick to the schedule, but we'll see. And it'll be a good way to generate a decent amount of videos really quickly. So let's jump into it. I'm gonna try to solve these in Python. Python's my second strongest language after JavaScript, and I feel like I'm decent at it. And I think, cranking these out, 25 of them, trying to do them under an hour, is great practice and might help me really level up to, if not intermediate, to like, advanced or expert level Pythonista or Python programmers. So let's dig in. So day 1, chronal calibration. We've detected some temporal anomalies. One of Santa's elves at the Temporal Anomaly Research and Detection Instrument Station tells you. She sounded pretty worried when she called you down here. At 500-year intervals into the past, someone has been changing Santa's history. The good news is that the changes won't propagate to our time stream for another 25 days, and we have a device. She attaches something to your wrist. That will let you fix the changes with no such propagation delay. It's configured to send you 500 years further into the past every few days. That was the best we could do on such short notice. The bad news is that we are detecting roughly 50 anomalies throughout time. The device will indicate fixed anomalies with stars. The other bad news is that we only have one device, and you're the best person for the job. Good luck. She taps a button on the device, and you suddenly feel like you're falling. To save Christmas, you need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. So this is actually kind of describing the whole thing. It feels like the whole Advent of Code. After feeling like you've been falling for a few minutes, you look at the device's tiny screen. Error. Device must be calibrated before first use. Frequency drift detected. Cannot maintain destination lock. Before the message, the device shows a sequence of changes in frequency. Your puzzle input. A value like +6 means the current frequency increases by 6. A value like -3 means the current frequency decreases by 3. For example, if the device displays frequency changes of 1, -2, 3, 1, Then starting from a frequency of 0, the following changes would occur. Current frequency 0, change of 1, resulting frequency 1. Current frequency 1, change of -2, resulting frequency -1. Current frequency -1, change of 3, resulting frequency 2. Current frequency 2, change of 1, resulting frequency 3. So it's like going up and down. In this example, the resulting frequency is 3. Here are some other situations. 111 results in 3. 11 -2 results in 0. -1, -2, -3 results in 6. Starting with a frequency of 0, what is the resulting frequency after all the changes in frequency have been applied? To play, please identify yourself via one of these services. I was going to use Twitter. If you have off problems that claim there is no request to token for this page, please clear your code and try again. Let's do GitHub. What would you like to be called? I think my handle. Join code, save. Okay, so that's the description. Please let me know in the chat if there's any sort of issues with the stream. Let's see, to stream help. Okay. So, to begin, get your puzzle input. So this is the input. And it just sounds like you just have to add them up. It's not too difficult. I feel like it's not too difficult. So let's just make a quick little Python program that can add them up. Advent of code. Advent of code. Zero, one. And so, well, so we're not really going for like good programming style or anything like that. We're just sort of trying to quick and dirty just solve it, right? So if this is the input, we might be able to just paste that into this browser. Oh, yeah, it did actually kind of hang when I was pasting that in. So maybe I'll just be a little bit more patient. So there's a delay. There's a considerable delay when I paste. Yeah, okay, interesting. So let's say hypothetically that I kind of just want to make a list with these items in it. So I'm gonna use all the resources at my disposal, and I'm gonna go ahead and use my Vim skills to actually define this, because I feel like there's no I feel like that's valid. So I'm going to replace basically every end with and sort of insert a comma. right? And so now we have a list of numbers, and I guess we want to drop the pluses because in Python the plus, I'm not sure if Python would do it, but we can easily remove them. Basically, I want to just, every single plus, I want to delete it. And then we still have the negatives. So this is a Python list of numbers. And then, I want to write that. And then I want to sort of print the sum of the input. We're doing it in Python. This is not, it's fair. 561. That's the right answer. You get a gold star. And there you have it, ladies and gentlemen. That was actually easier than I thought. Continue with part 2. Wait, are there multiple parts? Oh wait, there might be multiple parts. Interesting. Okay, you get 1 gold star. Part 2, you notice that the device repeats the same frequency change list over and over to calibrate the device. To calibrate the device, you need to find the first frequency it reaches twice. For example, using the same list of changes above, the device would loop as follows. 0, change of 1 resulting in 1. 1, change of -2 resulting in -1. -1, change of 3 resulting in 2. 2, change of 1 resulting in 3. At this point, the device continues from the start of the list and then applies these. 3, change of 1 resulting in 4. 4, change of 2, -2 resulting in 2, which has already been seen. In this example, the first frequency reached twice is 2. Note that your device might need to repeat its list of frequency changes many times before a duplicate frequency is found. And that duplicates might be found while in the middle of processing the list. Here are other examples. 1, -1 first reaches 0 twice. Oh, okay, so the first thing that is encountered more than once. 3, 3, 4, -2, -4 reaches 10 twice. Reaches 5 twice, reaches 14 twice. What is the first frequency your device reaches twice? Although it hasn't changed, you can still get your puzzle input. So same input, and it's asking what's the first frequency that is encountered twice. And if I feel like it's after running the full sequence. So for the device, and then we put in all of this entire sequence once, and then when we do it the second time, what is the first frequency that is a collision? So yeah, that's a little bit more involved. So I guess we need to track the frequencies, which is not something that I was doing. I could basically maybe track that in a list. Frequencies is this. And then for frequency in input, so frequencies start with 0, and I guess I'm gonna have an offset. I think it does start at 0. And I was thinking maybe having them correspond 1-to-1 to the input, but I think I'm gonna have to have it off by 1. For frequency and input, I want to apply the frequency. So frequencies dot append should open the documentation. Well, that's another way to open a window. I don't think I need the input. I don't think I need this. I do want the documentation. And I do want to have the Python documentation. And so I'm not sure if append is the right way. I'm gonna actually, because I do want to keep an eye on the live stream, I do want to put this over there. Okay, so that's working. So, okay. Yeah, so how do you insert into an array? Push. Python add item. Yeah, I thought it was append, but it's not showing up. It's like a built-in. Built-in functions. Append. It's not one of the built-ins, but it feels like I can just append. Just is blah. And yeah, I don't know why the documentation doesn't show that. Anyway, so yeah, we should be able to append, and what we're appending, we want to compute the new frequency. So we kind of want the last. Do I want to index into this? I think I can do this like this. Just grab the last one. I think you do it like that from -1. And basically, yeah, I just want to grab whatever's the currently last item in the list. I want to sort of that plus the current frequency, or the next frequency. Yeah, the current frequency. Add that. And then, then we have frequencies, and we have sort of like this list that tracks the frequencies over time, over computing the input. And then we want to do it again, right? Do it again, but while we're doing it again, so there's the new frequency. trying to figure out how to name, what's the right way to name this stuff. Current frequency, and then the change. So there's a delta, so it's probably better to call it a delta. So frequencies, and then change, for every change in the input, where input is like changes. And I think I'm putting in the time to properly name these things because I think it's going to help me think more clearly. The change. Frequencies.pen, frequencies, the last frequency plus the current change. And then we do it again. And then I think we would then have a new frequency. The new frequency is this, right? And just so that, because it's gonna bother me if I don't make them consistent. Okay. So this is what it would look like if we just did it. If we just did it twice, but we're not just doing it twice. We also want to do a comparison. So if we've seen this new frequency before, break. The new frequency. So if the new frequency is in the list of frequencies, print. I want you to, that's the answer. Now, how do I do, the nice word for that is membership, testing for membership in a set. Is this thing in this other collection of things as a member? And there might be a convenient, I have Python has like a lot of these like convenient things. So like Python test membership, there's probably like a built-in for it. And I have a list, not a set. So if in, I think I could do in. So I'm just gonna double check if that's fine. So if I have 1, 2, 3, and tell me 4 in li, false. 1 in li, true. So yeah, you can do in to test membership. That's the cute Python way to do it. So I want to ask, is the new frequency in the list of frequencies? I want you to print the new frequency. And that's our first collision. Otherwise, and I guess break. But really, whatever the first thing prints is the answer, so I don't really care too much. Ooh. Yeah, so what do we get? Invalid syntax. If it's a condition. And this is Python 3, which is requiring parens for the print. It didn't do it. I'm just going to do a sanity check if I can see any output. Print running second round. Okay, so it goes through the first input, and then for change and changes, new frequency is equal to frequencies minus 1. So the last frequency plus the change. If the new frequency is in the list of frequencies, print new frequency. Maybe another way to sanity check things is to have a string and a variable, because you never know if the variable is like a null value. So answer. I guess I can add another sanity check here where, oh, so it should just do it in like indefinitely. So maybe 2 rounds of this input isn't sufficient to find a collision. Maybe it requires several rounds. So I'm not. This is gonna be noisy. That was gonna be. I was gonna sanity check that it's looping, but I'm pretty sure it's looping. I'll double check. Looping. So I should expect lots of trash in this. Okay, so that's the second time it goes wrong. I need to actually make this run many times over the input. So that sounds like a while. And it sounds like I'm probably gonna have to consolidate both of these loops. So I'm gonna delete both of these loops eventually, but I want to sort of set up the while loop. So basically, while how about collision is equal to false? There's no collision. While right, okay. Because the thing is, I don't like negatives, so how about no collision, which isn't much better, but I don't even know if that's how you spell collision. While we don't have a collision, loop. And I'm actually rusty on while loops, so because like when I'm doing APIs, I hardly ever do while loops. So I'm just gonna see if that's working. Wow. So I want to make an infinite loop. So while yeah, that's I don't like negative variable names and stuff, but I prefer that versus having a negative condition. So I made this a negative because I wanted to do like a while true loop. I'm more comfortable with that. And basically we want to update collision. Frequency 0. For change and changes. Okay, so while there's no collision, I want the next change. So I need a loop. I need a while and a loop. It feels like I need to somehow track an index into into changes. I wonder if I can just use an iterator, but I'm not very comfortable with those. So I think I'm just gonna keep track of the index, and then whenever it reaches the end, just like loop it that way, because I don't want to start reading documentation right now. So while there's no collision, and then there's also the index is like, we're gonna initialize it to 0. While there's no collision, let's compute the new frequency. And that is going to be equal to the frequencies, or the last frequency, because we're still updating, inserting into our list of frequencies up here. So we keep track of a list of frequencies, we have a condition to while over, and then we're going to keep track of the index over the changes, the deltas. And then while there's no collision, determine the next frequency. The next frequency is equal to the last frequency plus the current change. And that is going to be equal to, that's where we're going to use this index here. Yeah, the new frequency. So that's the new frequency. And then if new frequency is in our list of frequencies, actually, that's the answer. So I'm going to just go ahead and say, to print out that answer, if the new frequency is in the list, if we've seen the new frequency, go ahead and print that. I think I can just break, but I'm not 100% sure on the Python syntax for breaking out of a while loop and an if or whatever. Otherwise, we are going to append this frequency into our list of frequencies. And you know, I guess no collision would then be false. So yeah, I'm not sure if the break would break out of the while, but if it doesn't, here's the other way that I was sort of thinking about it, so utilizing this no collision, and that would definitely break out of the while because we've seen a collision. Frequencies.append. We would have to increment the index. Yeah. Conditionally. So if index equals the length of the changes, right? So index starts at 0 and then the length. So like if we had 3 changes, I'm using a notepad offline. If we had 3 changes, so len returns 3, and then index starts at 0. If we have 0, 1, 2, so if index equals 2, I want to reset index to 0. So if index equals length minus 1, I'm going to reset index to 0. Otherwise, we're going to increment the index. And hopefully that loops over the changes until there's a collision. I commented that out just in case I needed to reference it later. And let's see. Okay, so it's crunching. I don't know how long to crunch. But it's crunching. And while it's crunching, we can double check our logic. So we have changes, a list of changes, and then we have a list of frequencies, and no collision equals true. There's no collision, and then index equals 0. While there's no collision, the next frequency is equal to the last frequency, 0, plus the first change. If the new frequency is in our list of frequencies, that's a collision, and we print out that. We also set new collision to false, just in case, and we break just in case. Maybe that's not necessary. Otherwise, we're going to go ahead and append frequencies, the new frequency to frequencies, if the index is equal to, I wonder if this ever happens, if the index is equal to, if we have 3 items, that length would be 3 minus 2. If we're at the last index, index is equal to 0. Otherwise, index is equal to the next index. Let's try to do a sanity check and figure out the first part using this loop. So so as a sanity check, I could print here, end of first round, we would get an answer like this. Yeah, it was a sum. I guess it would be the final frequency, because this is all additive. Well, it finally hit a collision at 563, so I was going to give up on it. That's the right answer. Wow, that's very surprising. My computer is very hot. You have completed day 1. You can share this victory. Like, literally, my computer is hot. It was running that loop. That was a tight loop. Okay, so my logic was right. I was gonna double check it. I was gonna do some sanity checks. So that's it, folks. That's the first day of Advent of Code. That is I think that's the full solution. 40 minutes. See you hopefully tomorrow. Have a great day.